Cambridge Primary Science. 4th grade. Activity book. Solids, liquids and gases. 3.1 Matter. What is matter? Matter is everything around us. Words to learn. Matter, solid, phase, gas, liquid. A brick is a solid. Water is a liquid. The air inside the bubble is a gas. Matter exists in 3 different states. A state of matter is called a phase. These phases are known as solid, liquid, or gas. It is Sunny's 10th birthday party. Identify 2 solids, 2 gases and 1 liquid on his birthday table. Gases in air. Air is everywhere around us. Air is a mixture of different gases. We can't see or smell the gases in air. A gas called nitrogen makes up of the air. 4. Air also contains a gas called oxygen. We need oxygen to live. We breathe in oxygen. We breathe out a gas called carbon dioxide, which is also found in air. Some gases do have a color. Some gases also have a smell. Hydrogen sulfide smells like rotten eggs. Hydrogen sulfide. Chlorine gas is yellow. Activity 3.1. Making carbon dioxide. Put some bicarbonate of soda in a surgical or rubber glove. Then, fill the glass bottle halfway. You will need vinegar, bicarbonate of soda, a glass bottle, a surgical or rubber glove, an elastic band. With vinegar, attach the glove carefully to the bottle using an elastic band. Ensure that you do not mix the bicarbonate of soda and the vinegar whilst attaching the glove. Once attached, shake the bicarbonate of soda into the vinegar. Observe what happens. The gas you have made is carbon dioxide. Questions. 1. What state of matter is A. Vinegar. B. Bicarbonate of soda. C. Produced in the reaction. 2. Draw a picture to show what happened when the vinegar and bicarbonate of soda mixed together. Label the liquid and the gas. What you have learnt. Matter is everything around us. Matter can exist in 3 different phases. Solid, liquid or gas. Air is a mixture of different gases. Talk about it. How do you decide if something is a solid, a liquid or a gas? 3.2 Matter is made of particles. A particle is of something. Small, very. Part. Words to learn. Particle. Scientific model. Scientists can use a scientific model to explain how and why something happens. The particle model is a good way to explain the differences between solids, liquids and gases. This model says that all matter is made up of particles. In real life, the particles in matter are too small to see. In the model we can show the particles as little balls. The particles in matter are always moving, even in things that look still. The amount of movement of the particles decides whether something is a solid, liquid or gas. Particles within a solid are packed together very tightly in fixed positions. This makes it difficult for the solid to change shape. Particles within a liquid are close together, but they can slide past each other and change places. Because of this, liquids can change shape easily. Particles within a gas are spaced far apart. This is why gases can have any shape. They can also be squashed easily. Activity 3.2. The particle game. Divide into groups. Imagine that each person in your group is a particle in a solid, a liquid or a gas. Look at the pictures to see what to do. Solid. Liquid. Try to shake from side to side. What do you notice? Gas. Try to move closer together or further apart. What do you notice? Try to change the shape of your group. What do you notice? Now change group and repeat the activity. Questions. 1. Compare what happened when you tried to shake as solids, liquids and gases. 2. What happened when you tried to move closer together in each case. 3. What happened when you tried to change the shape of each of your groups? What you have learnt. All matter is made up of particles. Solids keep their shape as the particles do not change position. Talk about it. How does the particle game demonstrate the particle model of matter? Liquids can change their shape as the particles are able to slide past each other. Gases can have any shape as the particles move far away from each other. Gases take on the shape of their container. 3.3 How do solids, liquids and gases behave? Can matter change its shape? Solids. Try to squeeze your desk, chair or pencil. Can you make it a different shape? Most solids can't be squashed into a different shape. Remember the particle model. Particles within a solid are packed closely together. There is no space for the particles to take on a different shape. Liquids. Predict what will happen when you pour some water onto a flat surface. Word to learn. Bubble. Pour. Amina, I can make water change its shape. No you can't, Serena. Activity 3.3 Prove that water can change its shape. Plan a demonstration to prove that water can change its shape when you pour it. Decide on the equipment you will use and what you will do. Now carry out the demonstration. Use the particle model to explain why liquids can change their shape. Gases. If gases are contained in something, they take on the shape of the container. Look at the picture. Here the gas is contained inside the bubble. When there is no container, gases spread out. Activity 3.3b. Observing how gases behave. Dip the ring into the soapy water. Blow air through the ring to make bubbles. What is the gas inside the bubbles? What happens to the gas when the bubble bursts? Questions. 1. Draw a picture of particles of air inside a bubble. B. Draw the same number of particles of air when the bubble bursts. 2. Why can't you change the shape of a brick by squeezing it? 3. Draw a labeled diagram to explain how a puddle forms when it rains. What you have learned: most solids do not change shape. Liquids take the shape of the container they are in or spread out over a surface. Gases only have a shape when they are contained within something. You will need soapy water rings for blowing bubbles. Challenge. Gas is sometimes used as a fuel for cooking. Why do we keep this gas in sealed metal containers? Talk about it. How do you think it is possible to squeeze some solids into different shapes? 3.4 Melting, freezing and boiling. Sabera's ice cream started as a frozen solid. When the sun heated the ice cream, it changed to a liquid. This change from solid to liquid is called melting. We can show melting in this way. Solid. Heat causes melting. Liquid. Freezing is the opposite of melting. Freezing is words to learn. Melting. Freezing. Steam. Boil. Water exists in 3 different when something changes from a liquid to a solid phases: ice, solid, water, liquid, and water vapor, gas, which we often call steam, often call. Activity 3.4 What happens to ice when it is heated? You will need ice cubes, pot, pan or saucepan, hot plate. Put the ice cubes into the pot. Heat the pot on the hot plate. Predict what you think will happen to the ice. What does happen to the ice? This is the phase change the ice goes through when you heat it. Solid phase. Ice. Safety. Be careful of the hot plate, it can burn you. Steam can also burn you. Heat. Liquid phase. Water. Now heat the water until it starts to boil. Observe how the water changes. Activity 3.4b. What happens to steam when it is cooled? Your teacher will hold the shiny board in the steam. Predict what you think will happen to the steam. Observe what happens. Safety. Put the liquid you collect in the freezer for 30 minutes. Predict what will happen to it. Questions. You will need steam from boiling water, a board with a shiny surface, a plastic container, black circle, a freezer, Be careful of the steam, it can burn you. One copy and complete the sentence below. Fill in the phase changes the water went through when it cooled down. Steam. Phase. Cool down. Phase. 2. What happens to the water when you put it in the freezer? 3. Copy and complete the sentence below. Fill in the phase changes the water went through when it froze. Water. Phase. Cool down. Phase. What you have learned: melting occurs when a solid is heated and it changes into a liquid. Boiling occurs when a liquid is heated and it changes into a gas. Talk about it. How does the particle model help us to understand melting and freezing? Freezing occurs when a liquid is cooled and it changes into a solid. 3.5 Melting in different solids. Activity 3.5. You will need an ice cube, a square of chocolate, a cube of butter, 3 pans, 3 hot plates, a stopwatch or digital watch. Be careful of the hot plate, it can burn you. Safety. Word to learn: gold. Compare melting in different solids. Place an ice cube in a pan. Do the same with the chocolate and the butter. Predict which substance you think will melt first when you heat it. Start heating each substance at the same time. Record the time you start. Observe carefully. Record the time taken for each substance to completely melt. Delta. Melting ice. Melting chocolate. Melting butter. Record your results in a bar chart. Questions. 1. Describe the phase change that each substance went through when you heated it. 2. How did you try to make this investigation a fair test? 3. In what ways was the investigation not a fair test? 4. What will happen to the water if you continue heating it? Even metals like gold and iron will melt if they get hot enough. Metals have to be heated in a furnace to melt. When the melted metal cools, it becomes a solid again. Gold. Gold 0.5. Gold. This gold was heated until it melted. Then it was poured into molds. The gold cools in the mold and becomes a solid again. These solid gold bars are called ingots. Here are the phase changes the gold has passed through. Solid, heat, liquid, cool, solid. What you have learned: some solids take longer to melt than others. Even metals melt if they get hot enough. Talk about it. Why do you think different substances take different times to melt? Boiling point. 3.6 Melting and boiling points. Every substance melts and boils. Different substances take different times to melt because it takes different amounts of heat to melt them. The amount of heat in a substance is called the temperature. The temperature at which a substance melts is its melting point. This is when it changes from a solid to a liquid. The temperature at which a substance boils is its boiling point. This is when it changes from a liquid to a gas. Words to learn. Melting point. Celsius. 50, 40, 30, 20, 10, 888,888,888. 50, 0, 10, 20, 30, 40. This is water boiling. Water has a boiling point of 100 degrees Celsius. We measure temperature with a thermometer. The unit we use is degrees centigrade, degree C. Activity 3.6. Measuring the temperature of water. Put some water in a cup. Measure the temperature of the water with the thermometer. Record the temperature in degree C. This is the temperature of the water at room temperature. You will need water, a cup, ice cubes, a pan, a hot plate, a thermometer, tongs. Put the ice cubes in a pan and heat them. As soon as the ice cubes have melted, remove the pan from the hot plate. Take the temperature of the water. Record the temperature. This is the melting point. Now heat the water until it boils. Take the temperature of the steam. Record the temperature. This is the boiling point. Safety. Be careful of the steam. It can burn you. Questions. 1. What temperatures did you record for? At the melting point of water. B. The boiling point of water. C. Water at room temperature. 2. Draw a bar chart to show these three temperatures. 3. The melting point of water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. Did you measure these temperatures? If not, why do you think the temperatures you measured were different? 4. Why should you never put your hand in steam? What you have learnt. The boiling point is the temperature at which a substance changes from a liquid to a gas. The melting point is the temperature at which a substance changes from a solid to a liquid. Talk about it. How does the particle model help to explain a melting point? 3. Check your progress. 1. Which of the following substances are solids? Which are liquids and which are gases? Oil, plastic, paper, carbon dioxide, oxygen, vinegar. 2. Which of these statements describes a solid, a liquid, or a gas? 3. 4. A takes on the shape of the container. B. Spreads out in all directions. C. Does not change shape easily. D. Is often colorless. E. Cannot be squashed. A. What are the three phases of water? B. What is the boiling point of water? C. What is the melting point of ice? A. Does the diagram below represent a model of a solid, a liquid, or a gas? B. Write a sentence to explain your answer. 5. Amul and Zhao want to compare how long it takes to melt margarine and butter. They want to plan a fair test. A. Which of these actions should they take? You can choose more than one. A. Put equal amounts of butter and margarine together in a pan. B. Put equal amounts of butter and margarine in a pan and a pot. C. Put equal amounts of butter and margarine in two identical pans. D. Heat both pans one after the other on the same stove. E. Heat each pan on an identical stove starting at the same time. F. Heat one pan on a gas ring and the other pan on an electric plate starting at the same time. B. Draw diagrams to describe how the butter changes from a solid to a liquid. Use the particle model in your diagrams.